Copy 724, right. Center maintain 2000.
Center maintain 2000, 74.
Comment 504 to center maintain 3000.
3000, comment 504.
In this video, we're going to be starting a new section, Aerodynamics. The first thing I wanted to cover is we should be able to name 4 dynamic forces. Okay, that act on an airplane during all maneuvers. So those famous 4 forces are lift. The second one is gravity. Then we have thrust, RUST, and last we have the drag. So the lift is going to be the upward acting force. The gravity is going to be the downward acting force. Thrust is going to be the forward force, and the drag is going to be the kind of the counter force for the thrust, which is going to be the backward force. So they may ask you like what are the flight conditions where the sum of the opposing forces become equal, where we have equal opposing forces. Okay, so you can say that the steady state, straight, and the level unaccelerated flight, the sum of the opposing force is going to be the equal, and it's going to be equal to 0, right? Otherwise, like wherever, like the if like there's going to be there's going to be some movement, there's going to be some acceleration too. Maybe if any of the forces, opposing forces does not have a sum equals to 0, in that direction we're going to be having the movement, actually the acceleration. Then what is an airfoil? So basically you can call it a device, right? Just to come up with we're trying to come up with a definition here. So we can call it a device, which actually gets a useful reaction from air moving over its surface, right? And that useful reaction is the lift. So airfoil, the examples of the airfoils are going to be the wings as an example, the tail as an example, the tail surfaces, vertical tail surfaces, propellers, they all have airfoils. Again, like in a layman term, it is the shape of the wing, or these tail surfaces or the propeller, which actually creates a lift. What is angle of incidence? Incidence. Okay, for this one, let's draw a picture. It is basically, let's say if this is our plane, right? If this is the plane, there is a thing called chord of the wing, right? So if you look at this wing, this is because it is definitely possible that if you look at the plane, and this is how that the plane, like the structure of the plane is like this, it is very much possible that the wings are at this direction. So we are actually, this line is representing that angle of the wing, right? So we're going to be calling it as chord of the wing. And the second one is actually chord, sorry, the angle of incidence is actually this angle, right? So there could be it's you can call it the longitudinal axis of the airplane. If this is the longitudinal axis of the airplane, and this is the and the and the wing is like the longitudinal axis. This is the longitudinal axis, and this is the chord of the wing. So the angle between them is known as the angle of incidence. Again, it is an angle formed by the longitudinal axis of the airplane and the chord of the wing. Okay, now we're going to be covering the next one, which is the relative wind. So the relative wind is the direction of the airflow with respect to the wing, right? Let's say this is our horizontal axis of the plane. This is the angle of the plane. Sorry, angle of the wings, right? And again, this is gonna be the angle of incidence. And so just focus on this one. Where, let's say this is our wing, right? And this is actually this. So you are looking from here, this side. If this is the wing of the plane, right? So you are looking at this side, right? So if it's gonna be looking like this, so the relative wind is gonna be the whatever the direction of the wind is compared to this thing. Wind can be here, wind can be here, wind can be anywhere. So the relative wind is the direction of the airflow with respect to the wind, to the wing. So when a wing is moving forward and backward, is moving forward, backward, and backward, the relative wind moves backward and forward. So you can think of it as like the flight path and the relative wind. They always like they are always parallel but travel in the opposite direction. Then we have to define and understand the angle of attack. Okay, the angle of attack is the angle between the wing chord line and the direction of the relative wind. Again, if you think of this as the wing chord line, so whatever that relative wind is hitting and creating an angle, that angle is gonna be the angle of attack. Now we wanna talk about Bernoulli's principle. So basically what it says is that the pressure of fluid, basically the in this case we're going to be talking about the gas, right? The pressure of the gas decreases by decreases at points where the speed of the gas increases. What they're saying is like the air is gonna be coming like this, right? Some air is gonna be going at the bottom, right? So again, I'm gonna repeat the same thing again, that the pressure of of the gas is gonna be less where the speed of the uh, gas is gonna increase. That's basically the Bernoulli's principle. So you can think of it as like because of this airfoil of an aircraft is designed to increase the velocity of the airflow above the surface. So the wings are designed so that the speed of the gas or the speed of the air is gonna be more, so the pressure uh, of that air is gonna be less at the top of the wing, whereas at the bottom of the wing the speed is gonna be less, the pressure is gonna be more. So because the pressure is gonna be less on the top, it's gonna help by providing us the lift, and it's gonna help the airplane become airborne. Okay. Factors affecting lift and drag. Again, the lift is the forward force, the drag is the backward force. I'm just gonna point it out. The first factor is the wing area, area. Again, we'll come back to it in a little bit. Let me just write it down. Shape of the airfoil. Okay, then we have angle of attack. Then we have the velocity of the air. Then we have air density. Then we got, yeah, these are the things which is gonna affect both the lift and they are mostly self-explanatory. The wing area, uh, basically it is proportional to the both of them, the lift and the drag. They are acting on the wing are roughly proportional to the wing area, right? If the wing area is gonna be big, both forces are gonna be big. Shape of the airfoil. As the upper curvature of an airfoil is increased, the lift produced increases. Okay. Angle of attack. As angle of attack is increased, both the lift and the drags are increased. So again, if this is the horizontal axis of the plane, and the more inclined the wing is gonna be, both the forward, the uplift, and the downward and the drag is gonna start increasing. So angle of attack, and then velocity of the air. An increase in velocity of air passes over the wing, increases lift and drag. Again, both of them are gonna be increasing with the velocity of the air. And the air density, lift and drag vary directly with the density of the air. As air density increases, lift and drag increases. Yeah, other than the shape of the airfoil, all of them kind of proportionally increases both of, like, basically increases both lift and the drag. Okay, what is the torque effect? So torque effect involves the Newton's third law of physics. For every action there is an equal and opposite reaction. So applied to the airplane, this means that as the internal engine part and the propeller are revolving in one direction, an equal force is trying to rotate the airplane in the opposite direction. It is greatest when at low airspeeds with high power setting and high angle of attack. So again, the propeller is moving in one direction, so there's going to be another force which is going to be trying to move the airplane in the other direction. That effect is known as the torque effect. So a little bit talking a little bit we're going to talk a little bit more about this effect. So what is the reaction of this, right? This torque effect. So there are two things. In flight, what happens is like the torque reaction is acting around the longitudinal axis, right? Tending to make the airplane roll. To compensate, some of the older airplanes are rigged in a manner to create more lift on the wings that is being forced downward. So they actually used to have the like a hard coded way of resolving this issue. In the modern airplanes, the engine offset, there's an engine offset to counteract this effect of torque, right? And on the ground, what happens is like during the takeoff roll, an additional turning moment around the vertical axis is induced by the torque reaction, as the left side of the airplane is being forced down by torque effect. More weight is being placed on the left main landing gear. This results in more ground friction or drag on the left tire than on the right, causing a further turning moment to the left. So this is the effect of that torque effect we have when we are on the ground. Okay, what are the four factors that contribute to the torque effect? Factors which increase the torque effect. Okay, torque reaction of the engine and propeller, right? There is one. Engine plus propeller, right? And then we have the gyroscopic effects. Third one is the corkscrewing effect. And the fourth one is the asymmetrical loading of the propeller. Okay, so the first one, which is the torque reaction of the engine and the propeller. For every action there is equal and opposite reaction. The rotation of the propeller to the right tends to roll and bank the aircraft to the left. This is what basically we talked about when we were talking about the definition of what the torque effect is. The second one is the gyroscopical effect. So gyroscopical precision applies here. The resultant action and deflection of a spinning object when a force is applied to the outer rim of its rotational mass. If the axis of a propeller is tilted, the resulting force will be exerted 90 degrees ahead in the direction of the rotation and in the same direction as the applied force. It is basically this effect is notable on takeoffs in the tail draggers when the tail is raised. This corkscrewing effect of the propeller is like high speed rotation of airplane propeller results in a corkscrewing rotation of the slipstream as it moves rearward. At high propeller speeds and low forward speeds, this slipstream strikes the vertical tail surface on the left side, pushing the tail to the right and yawing the aircraft to the left. And the last is the asymmetrical loading of propeller. When an airplane is flying with a high angle of attack, the bite of the downward moving propeller blade is greater than the bite of the upward moving blade. This is due to the downward moving blade meeting the oncoming relative wind at a greater angle of attack than the upward. So basically there is a greater thrust on the downward moving blade on the right side, and this forces the airplane to yaw to the left. Mostly they are going to be all these effects are going to be yawing the plane to the left. Centrifugal force. The definition is like the equal and the opposite reaction of the airplane to the change in the direction, right? And it acts equal and opposite to the horizontal component of lift. So the force where you're gonna be whenever you're gonna be changing the direction, the force which actually tries to counter that is called the centrifugal force. We're going to be covering two more here. One is the load factor. So it is the ratio of the total load supported by the airplane's wing to the actual weight of the airplane and its contents. So it's the ratio of the load supported by wings divided by total total weight of the plane, and that would dictate the G, like where exactly is gonna be the center of the gravity inside the plane. So again, you can think of it like it's gonna come out to be have some. So it can be expressed as the ratio of a given load to the pull of gravity, right? To refer to a load factor of 3 as 3 G's. In this case, the weight of the airplane is equal to 1 G, and if a load of 3 times the actual weight of the airplane were imposed upon the wing due to the curved flight, the load factor would be equal to 3 G's. Okay. And the last thing we wanted to cover is what are the two main reasons that this load factor is important to pilots. One is like if you dangerously overload it, right? That is possible for a pilot to impose on the aircraft structure. So we definitely want to avoid that. And the other one is because an increased load factor increases the stalling speed and makes stalls possible at seemingly safe flight speeds. Yeah, these are the things we wanted to cover in this video.